Hey, thanks for joining Con 223 here with us at reInvent. Today we're going to talk about AWS XRay and Amazon CloudWatch and increasing visibility for ECS Fargate. My name is John Fermento. I am a solutions architect here at AWS and lucky enough to be presenting with my customer Vanguard and even have Justin Federico, a senior developer from the Vanguard group here with me presenting, and I'll introduce him a little bit. For today's session, we're mainly going to tee it up with the history of Vanguard in a nutshell, do it very brief, talk about some of the tools we selected, and you probably already have an idea, XRay and CloudWatch. Talk about how we leverage the Vanguard crew to scale the implementation for this project. Justin has a great demo teed up for us that will actually show us how Vanguard leverages tools and the value that you can get from them. Then we'll talk about the results, and then I'll come back for a brief wrap-up. So the history of Vanguard. First of all, if you're not familiar with Vanguard, they're one of the world's largest investment companies, offering a large range of low-cost mutual funds, ETF, and financial advice and related services. Vanguard has over 30 million investors in 170 countries, and as of January 2020, had over $6 trillion in global assets under management. Now, the Vanguard started their journey in AWS quite a few years ago, and then in 2019, adopted a microservice strategy that had selected ECS on Fargate as one of the key components or platforms to deploy these microservices on. And this really allowed Vanguard to unlock efficiencies, as they no longer had to worry about the undifferentiated heavy lifting of managing compute resources at a granular level. It can really focus on building, really high-performant, feature-rich applications for their large customer base. And so, as part of this, migration from an on-premise legacy container system where this started, or platform, onto ECS and Fargate, Vanguard initially started leveraging some of the traditional monitoring and logging applications that they were leveraging for this legacy, platform. And we all knew going into this that we'd have to reevaluate and adopt cloud-native monitoring, logging, and essentially observability tools to reach the full potential. And that's the story we're here to tell. But first, I wanted to line up and level set on the platform for those who aren't familiar. So Amazon Elastic Container Service is a cloud-native, high-performance, highly scalable container management platform that makes it easy to run, stop, and manage containers at scale. And you define your container in a task definition that allows you to run individual tasks within a service. And then in this context, a service is the configuration that enables you to maintain a specific number of tasks simultaneously in a cluster. And then Fargate on top of that is a technology that allows you to run ECS containers without having to manage servers or clusters of servers. And this basically takes away the undifferentiated heavy lifting of managing the underlying compute. So you no longer have to worry about provisioning, configuring, or even scaling your clusters, and Fargate takes care of all that for you. And this allows you to really focus on building your applications and not worrying about scaling and configuring infrastructure. So the reason why we're here, right? We obviously had some troubles with the legacy tooling, and there are three I'd like to call out. So the first was the high cost of data ingestion. As more and more workloads were going onto AWS, the cost of running or leveraging these monitoring tools became expensive because more data was being ingested into these tools. And then there was a lack of visibility into the microservice applications. So as we deployed more and more applications and we were re-architecting using like a microservice architecture, it became evident that we needed a solution for tracing calls between microservices. And the legacy tools did not provide an easy way to instrument code and provide cloud-native reporting that we needed and Vanguard needed to operate at scale. And then the last one was there was high latency for data ingestion into these legacy tools. And this was just really on the way the solution was architected, but it took time from when the data was created in AWS, whether it be a log from an application or infrastructure, to then be ingested into the legacy tool for consumption. So with these three things in mind, I started engaging with the team, Justin's team at Vanguard, to start focusing on these and bring some solutions to the table. So next, I'm going to pass it to Justin to talk about exploring some cloud-native options.
Thank you, John. So being one of the early adopters of ECS Fargate here at Vanguard, we were one of the teams that really saw these issues that John mentioned come to light rather quickly. And so we really saw this hinder our ability to really take full advantage of ECS and services like that. So that's when we decided to meet with John and our AWS Solutions Architect team to see if there are any viable tools that we could use to help solve some of these issues. During these sessions, we would cover the tools that we were currently using, what we were using them for, any potential issues and problems we were seeing using the tools, and then hopefully what we wanted to see in any new tools that we adopted. Going through these sessions, the Solutions Architect team was able to provide us a few tools that they felt might meet the criteria we were looking for. And so a few of those tools that we took back and what we'll talk about for the rest of this presentation are AWS XRay and Amazon CloudWatch. So I wanted to give a high-level overview of these tools because we're going to be talking about them for majority of the presentation. So AWS XRay is a visibility tool that will allow you to see your requests as they go through your service, and it will provide some basic information throughout that request lifespan. For Amazon CloudWatch, it's a log aggregation tool, so it will allow you to build custom dashboards, metrics, graphs, alarms, and really allow you to visualize your application's log messages. So when we had these two tools in mind, the next step that we wanted to do was actually pilot these tools and pilot them on real applications. We already had a few ECS services running in production, and so we really wanted to make sure that any tools that we wanted to adopt would work well with our pre-existing architecture and system. And there are several reasons why we chose these two tools in particular. For AWS XRay, it was all around maintenance and customization. So with our legacy tooling, anytime there is an update, whether it be a security fix, a bug patch, or just a general update, we would need to then update our application code. And then whenever we updated our application code, we'd have to take it through our QA cycles and then eventually elevate it to production. So this was a lot of time taken away from the developers anytime there's an upgrade. With AWS XRay, since it's a managed service from AWS, all we had to do was simply enable the service, and that's pretty much it. There might be a time where there's an SDK upgrade where if we wanted to take advantages of some new features, we might have to upgrade, but outside of that, there really was low maintenance, and that was key for us. Another area that we really liked was the customization that XRay provided. So in XRay, you can provide your own custom annotations, and these are really key value pairs that you can set through the code that then you can filter requests by an XRay. So a real common example for this would be like a query parameter into your web service. And we thought this would be a real viable solution for us when it came to troubleshooting, because we could filter all the requests and only the requests that we cared about. So we could get those detailed information rather quickly. And a really nice feature of XRay is its service level visibility. It can automatically generate a service map by tracking your request and how it goes through all your AWS systems. And this is done automatically, which is great because we can quickly get a glance of all the systems our requests are interacting with. And it provides really great detail on how long that request is staying in that service, the response codes that those services are returning. So it gives us a really good opportunity to see where any potential bottlenecks are or any performance issues that we can focus on. On the CloudWatch side of things, it was all about speed. So in our current legacy system, it could take around 15 minutes or so for us to get a notification that an alarm was triggered. And this is because by default, all logs will go to CloudWatch, but we actually had a process that would then extract and send those logs over to our third-party system. And by the time that system was able to curate those logs and be able to run the queries necessary to alert us of anything that we set, took some time. Our ECS services are client-facing, and for ours in particular, they were on what we deemed critical path. So the faster we could get alerted that a service was starting to become unhealthy, or there are certain data quality trends that we were trying to follow that could allow us to know there's a potential issue on the horizon, the quicker our team could react, and then we could be proactive about it and either turn off a future toggle or get a different service to be redirected so that we could minimize downtime for our clients. Having everything native on CloudWatch allowed us to really get the lowest level of latency possible for these situations. And of course, because since we're not sending logs outside of AWS, we figured that we would also save on costs. So we felt like we had a successful pilot run, and this was because we actually implemented these new tools in conjunction with still using our legacy tools. And that was important to us because we wanted to make sure that we could compare and contrast in real time all the metrics that we are already used to capturing and all the alarms that we're used to triggering the team whenever any potential issues were around. So by having both in parallel, we could make sure that there are no gaps left, and we felt really comfortable with the results. Once we felt comfortable with this, we then wanted to kind of share our knowledge and start to expand to other teams and employees here at Vanguard, as we like to call them, crew members. So if we take a quick step back to our pilot phase, we actually had multiple teams really interested in wanting to leverage these two tools. So we felt best that these teams would then pilot together. So this way we could come up with a real solid core knowledge base of all the basics. So things like just basic setup and getting the services enabled. And then in addition, each team is going to have their own needs and wants from these services. They're going to have their own styles to implement. They're going to have their own features they want to take advantage of. So having multiple teams in this pilot phase really allowed us to get a well-rounded solution and cover as much as we could for these services. Once we felt comfortable with the documentation, we then held these micro-learning sessions, and we wanted to really keep these small in scope because in the future, when teams come to look at enabling these services for themselves, they can really pick and choose what they want out of these features. So having real small sessions, for example, creating a custom XRay annotation or how to best log your application so you can create a CloudWatch alarm for them, really allowed teams to learn what they were interested in and what they wanted to take advantage of. And we could keep them really detailed and not have a lot of generic information that most teams would just end up tuning out. And then I think most importantly, from an enthusiastic side, we had internal roadshows. And this was really showcasing how we implemented these two services in our actual real life applications. And this drove a lot of enthusiasm because there was no smoke and mirrors. This was what we were really using. These were all the hurdles we faced. These are how we overcame them. These were the cool things we did with these services, and these are the really positive results we saw from that. We saw that this really drove engagement with other teams and senior management and really got them excited about these services and what we were trying to do. Before I jump into our demo, I just wanted to give a high-level overview of the architecture we'll be dealing with. So this is a real 10,000-foot view, so I'm going to zoom in a bit so we can concentrate on some of the specifics. In this diagram, we have two ECS services, Service A and Service B. Service A is our client-facing application, and it's going to call service B for additional processing, logic, and additional data. Both of these services have their own DynamoDB table that they query for data. And both of these services have XRay enabled, and we've gone ahead and coded a few custom annotations that we can track and filter our requests on. On the CloudWatch side, both of these applications are outputting specific log messages. And a real common use case for this is, for instance, having response times. So each service will log out how long it takes for a request to be processed in its system. And then we can tack on a CloudWatch metric on top of that to extract the response time value. So in this case, either metric X or metric Y. And then we can set up an alarm so that whenever those values exceed a threshold that we define, it will then go and trigger the alarm. Whenever you create an alarm, you assign an SNS topic to it. So whoever subscribed to that SNS topic will then automatically get emailed or notified whenever that alarm gets triggered. So in this case, our team gets notified via email whenever one of our CloudWatch alarms goes off. All right, so for our demo, we're going to cover the following scenarios. There's going to be a CloudWatch alarm that gets triggered and notifies the team. The team is then going to hop on to their CloudWatch dashboard and hopefully get some high-level insights on what potentially is causing the alarm to go off. Once we get that high-level insight, we're then going to try and focus our troubleshooting efforts and go into XRay to get that low-level information we're looking for. And then hopefully with that low-level information, we're going to be able to get to a root cause of what's causing the issue and then hopefully fix it. All right, so the team is going to get notified by CloudWatch that an alarm has triggered. So we're going to search for CloudWatch in the AWS console. And in the CloudWatch page, we're going to go to our dashboard section and click on our team dashboard that we created. Every widget that you see on our dashboard, you can easily move, adjust size. We separated everything between service A and service B, so we can easily compare and contrast the two. If you look at the service B side, specifically the response time, you'll see that this widget is highlighted in a red border. Any type of CloudWatch alarm widget, the border color will be reflective of the alarm status. So service B is red because it's in an alarm state, whereas in service A it's green because it's in an OK state. And if we look back at service B, we can see that the response time is exceeding our threshold that we set, which is 1.5, and hence it's in an alarm status. If we take a look at the response code pie chart, we'll see that service B is returning more 503s than we'd probably want. It's returning around 35% out of our total responses. So we have a pretty good high-level indicator that there's something going on with service B that's reflective of its health. We can take a few looks at some of the other dashboards and widgets here, so like CPU utilization and memory utilization. These two actually are automatically captured from AWS when you use ECS. So if we take a look at the metric itself, and over the label and details, we'll see that it's under the ECS metric tag. And so we can follow this in the metrics section. Under AWS namespaces, we can click on ECS and click on the cluster name service name. And here, because both service A and service B are running in ECS, they'll be able to select them here, and both memory and CPU are available. You can select as many as you want to chart on a single graph. It's really just personal preference and what you prefer to view. Similarly, you can create your own custom metrics. So we have our own Llama metrics that we capture, and we created custom metric filters based on the logs that we log out for our services. We can take a look at some of the other widgets available. With most log visualization tools, there's a lot of options on how we want to visualize the data. So you'll see that in CloudWatch as well. But for now, I think we have a good idea that Service B is where we should focus our troubleshooting efforts on. So now we're going to quickly jump over to XRay, and we can do that rather easily from the CloudWatch by clicking on the service map link on the CloudWatch tree here. So we'll click on service map, and here we'll see that there's an automatically generated map that shows how your requests are coming through to your services. So we'll see it go from the client to service A to a DynamoDB table to service B and to service B's DynamoDB table. If you highlight over any one of these service bubbles, you'll get some basic stats like latency, requests, and faults. And we can see that service B has some red indicators on it, so we have a higher percentage of faults, longer latency, especially when compared to the other services. So again, we're going to focus on service B, and we can click on the service itself here. And we'll get some basic time series graphs based on those three metrics, so latency, requests, and faults. But we can get some more detailed information if we click on the View Traces button. And in here we'll see we can filter by each request and certain attributes based on that request. Some of these are actually automatically captured from XRay, so HTTP method, response code, URL. These are just attributes that will be automatically captured when you use XRay. You can also create your own custom annotations in code. So we add it to ourselves, service and Llama ID. We're going to focus on Llama ID, and this is just the ID that we're querying our DynamoDB table with. And pretty quickly we can see that Llama ID 5 and 6 have a much longer response time compared to the others. So we're actually going to click on one of these and add it to our filter. And this is going to filter out all the requests that have this attribute value. So any request that has Llama ID 6. We only have one, so we're going to click on that to get individual request details. And very similarly, we'll map out the request, and this is a single request, so we can see exactly how it traveled through our system. And again, we can see issues with service B. And if we scroll down, we'll actually get a time series chart that just lays out how the request traveled and how long of the duration it took for the total travel time. Again, we can see that service B returned a fault, which is the 503 response code, and the duration is really high, especially compared to all the other services it interacted with. So at this point, we're going to check out the service B DynamoDB table, which is the Llama table. So we're going to swing over to DynamoDB really quick, check out the Llamas table to see if we can get some information. And when we look at the items, we're actually going to see that items 5 and 6 are missing. So temporarily, we're just going to quickly add them here. And so we added 5 and 6. And this is just to see, can this get us back afloat? So we're going to refresh our dashboard to see how service B is responding. And now we can see that our request time and response codes are looking much better. So now we have a temporary solution, and now the team can go debug and see what happens when items aren't found and address that. And that's how we're able to combine both XRay and CloudWatch together. So we've been running these two services in production for a few months now, and we've already seen some really positive results. On average, we've seen alerts be triggered 10 minutes faster. So in our legacy systems, we've seen about 15 minutes for our alarms to get triggered, and we've seen that dip well under 5 now. And again, this is all about how fast we can react to any potential issues that can affect our clients. And so saving those 10 minutes is really huge for us, and we've already seen really big advantages being able to react to before most teams are even aware that anything is going on. In a similar fashion, we've seen about a 50% reduction on time spent troubleshooting. So usually it would take us around 60 minutes or so to find a root cause of any issue. And we've seen that go under 30 minutes now. And a lot of that has to do with the fact that, hopefully, as you saw in the demo, everything is really all compacted in the same space. So we can travel from CloudWatch to XRay to logs really simply and fast. Whereas in our legacy system, all the tools that we used had a different look and feel. They had a different UI. They had a different login system. So if you hadn't used these tools in a while, it would take a little bit of time just to get your foot in back and get used to the syntax again to really find what you were looking for. And so the faster we can troubleshoot issues, the faster we can come to a more permanent solution and quickly increase our response time and uptime. And then on the cost sides of things, we're projecting that we're saving about $400 per gigabyte per logs in year. So this cost is mainly around having to export log messages from CloudWatch and out of AWS into a third-party system. And then in addition, having to pay for the storage to keep those log messages in that third-party system. So our team by itself, we own a few services that run 24/7, and they can generate a few hundred gigabytes by themselves per year. So you multiply that by a handful of teams, and this cost will really start to drive up. And of course, the more we save on cost, the more we can invest right back into our application and hopefully develop better features and enhancements for our clients and ourselves. So before I turn it over to John to wrap us up, I just wanted to give a huge shout out and thank you to my fellow crew members here at Vanguard, specifically Jeff and Kat. They were really instrumental in getting this pilot off the ground, and they really pushed the envelope to get us to where we are today. So thank you both, and thank you to the rest of my team here for supporting us throughout this journey. And with that, I'll turn it over to John to wrap us up.
Cool. Thanks, Justin, and great demo. Really appreciate it. So here, just to wrap up, first we looked at optimizing tools for ECS-based, ECS Fargate-based microservices, and that led us to Amazon or AWS XRay and Amazon CloudWatch to fill these gaps. Then Justin and the team, in cooperation with the AWS solutions architects such as myself and the rest of the team, worked on creating reference architectures for quick adoption and internal trainings and micro-learning sessions that the Vanguard crew could consume to get up to speed on these services quickly. And because of all this, Vanguard realized, great time savings and cost savings. And now thinking ahead, right, there's always something next. And now we're looking at, what's the next 6 to 12 months for the microservice platform of Vanguard. And I can tell you, we're looking at, working on standardizing ECS or EKS as a platform for adoption, and looking at other monitoring and logging aspects and continuing to roll out XRay and CloudWatch throughout the organization. But we're super excited to continue down this path over the next 6 to 12 months. But yeah, thanks for joining our session. Hope you enjoyed it.